and my metric number is 300155. I'm going to present our group assignment 1. So the first question is A1. Given the above model, describe the relationship between any two goods and justify your answers. My first answer is good 1 and good 2. A rise in the price of the good 1 by the 1 ringgit is expected to decrease its quantity demand of the good 1 by A. A rise in the price 2 is linked to decrease quantity demand 2 and increases quantity supply 2. So the relationship between the good 1 and the good 2 are substitutes because an increase in the price of the price 1 or price 2 was raise the quantity supply. Thus, there is a positive relationship between the price 1 and quantity supply 1. And my second answer for question A1 is good 1 and good 3. A rise of the price 1 is linked to decrease quantity 1 and increase quantity demand 3. There is a negative relationship between the price 1 and quantity demand 1. A rise in the price 3 will decrease quantity supply 1 and increase quantity supply 3. There is a negative relationship between the price 3 and quantity supply 1. So, the relationship between the good 1 and good 3 are complements because an increase equation is using the equilibrium conditions. We left a system of the three simultaneous equations in the price variables and transform them into the matrix form. So the good 1 equilibrium is quantity 1 equals to quantity supply 1. And then we got alpha 1 plus beta 1 P1 minus beta 2 P2 minus alpha 3 P3 equals to alpha 0 plus beta 0. And for the good 1, the equilibrium is QD2 equals to QS2. And then we got the equilibrium delta 2 plus gamma 2 T2 equals to the gamma 0 plus the delta 0. Equilibrium for the good 3 is QD3 equals to QS3. And then we got the phi 1 P1 plus sin 2 P2 plus phi 3 P3 minus sin 3 P3 equals to minus sin 0 minus phi 0. In the matrix form, we got alpha 1 plus beta 1 minus beta 2 minus alpha 3. And then 0, delta plus gamma 2, 0. And the phi 1, phi 2 minus phi 3 P3 minus phi 3 P3. P1, P2, and then P3 is equals to alpha 0 plus delta 0, gamma 0 plus delta 0, and then negative phi 0 minus phi 0. And there is an answer for the question 2.
And the question B1, using the equilibrium condition again, derive a system of three simulators equations in the three price variable and transform them into the matrix form. First, we should balance between the quantity demand QD and the quantity supply QS for each of the three goods. For good 1 and good 2, we get 100 equal to 3P1 minus 5P2 plus 2P3 for equation 1. And for equation 2 is 115 equal 4P2 from good 3 and good 4. And from good 5 and good 6, we get equation 3 is 120 equal 2P1 minus 3P2 plus 4P3. So we will transpose them equation into the matrix form. In this equation, the left matrix contains coefficients representing how change in price affect in the quantity demand and supply for each good. For the column vector on the right context, the context represents equilibrium quantity demand and supply. The column vector is in the middle context. The variable we are solving for the price of three goods P1, P2, and P3. For question B2, using a Cramer rule, solve from the equilibrium price. First, we calculate the demand of the conferences matrix. This involves finding the determine of a 3 by 3 matrix, which is a straightforward process. So we get the conferences matrix is 40x minus 6. So we get the conferences matrix is 48 minus 6 is equal 32 from the first row matrix. Next, we calculate the three determinants A1, A2, and A3 by replacing each column of the conferences matrix with the constant for the right side of the equation. This step involves finding the determinant of 3 by 3 matrix and find the equilibrium price by dividing each AI by A, where AI is corresponding to the column being replaced. For P1, seed 100 for 160, divide 32 and get 201 and 88. For determinant 2, we take the second formatry and get 2200 to get price 2. 100 to 100 divide 32 get 37 ringgit 50 cent. For price 3 is 5090 divided by 32 get 159 and 6 cent. So we conclude that P1 is 200 ringgit 88, P2 37 ringgit 50 cent, and P3 159 and.
My name is Zhu Zixian. My number matrix is 298788. I will continue part B, question 3. Using the matrix inversion method, solve the equilibrium prices. From matrix form we get AX equal to D. Find determinant and contactor, then substitute to formula X equal to 1 divide determinant A multiply contactor A multiply D. Finally, we get price of good 1, 201.88. Price of good 2, 37.5, and price of good 3, 159.06. Thank you for watching this video.